What's up, everybody? So, guys, in this video, we're going to be looking at transformations of both exponential functions and logarithmic functions. Most likely at this point, you've been introduced to transformations before. So hopefully this isn't going to be too new of an idea for you, but we're just going to be looking at how these transformations are, what they look like for these specific functions. So let's start with exponential functions. So remember when we're moving side to side, a horizontal translation, remember we always add or subtract numbers directly to the x, or sometimes we say inside the x. Remember though, with exponential functions, the x is the exponent. So if you see a plus or minus in the exponent, that's going to be a horizontal translation. On the other side, vertical translations go on the end, just like they always do with other functions. So it won't be in the exponent with the x, it'll be on the end, kind of separated. All right, reflections, remember there's two types of reflections. So we have when the negative sign is out front of the whole function, we say that it's reflected over the x-axis. And then if it's directly in front of the x, if the negative sign is just applied to the x itself, then we say it's reflected over the y-axis. We're going to skip horizontal stretches and shrinks. So when we talk about stretches and shrinks for this video, we're just talking about vertical stretches and shrinks. So a stretch would be multiplying any number bigger than 1 out front of the function. So we can see this function right here is stretched by 3. Now, be sure to realize that this isn't the base. The base is 2. If you have a base of 2, that doesn't mean that it's stretched. Okay. The stretch is the number in front of that, so it's the multiplied number out front. That's what's going to be applying the stretch. Also realize that the negative sign, if you have a negative sign out front, that's not part of a stretch or shrink. That's a reflection. Okay, and then shrinks, of course, would be number between 0 and 1. Number between 0 and 1. So like a fraction or a decimal smaller than 1. Okay, let's look at a few examples of this. So what is the transformation? So if this is the transformation and this one was the original, what did we change here? Well, the 1/2 x is just the 1/2 x. That's just the original function. But then we have a -4 on the end. So we would say that this -4 means that we're moving down 4. So remember, if it's on the end, it's up and down. All right. Okay, here's our original, e to the x, and then here is our transformation. So we can see that we have a +3. Actually, I like to start on the right side, so let's start on the right. +2 on the end means up 2. So we're moving it up 2, vertical translation. And then also we have a +3 inside the x, inside that exponent there. That means that we're going to be moving left 3. So remember that it's left and right if it's inside the x. So left 3, and it's left because it's backwards. So +3 would be left, -3 would be right. Okay, so there we go. We got up 2 and left 3. All right, let's see what we've got here. So this is the original. This is how we've changed it. Actually, we're going to skip this one because this one has a horizontal translation in it. Let's do part B instead. So we'll just go ahead and white this one out. All right. So here's the original, and here's how we changed it. So notice that we have a 1/8 added in there. That 1/8 is going to be a shrink. Remember, if you multiply it by a number out front, that's either going to be a shrink or a stretch. So this is going to be a shrink by a factor of 1/8. And then we also have a negative sign out front. This negative sign out front is going to be a reflection. We'll just say reflect, and then over the x or y axis. So if the minus sign is out front, remember that that's going to be on the x-axis. It's a reflection on the x-axis. Okay, you might be saying, well, what about this minus sign right here? Well, notice the original function already has a minus sign, so we didn't change it. We didn't transform it from that. So we're not looking at that minus sign. We're just looking at what changed. All right, now let's look at the same idea with logarithms. With logarithms, again, side-to-side movement is going to be inside the x. So notice it'll be like inside these parentheses, inside that logarithm, inside that function. Whereas if we're moving up or down, it'll just be on the end. So it won't be included with the x. It won't be in these parentheses. Okay, reflections, same idea. If the minus sign's out front, it's going to be x-axis. If it's right in front of the x, that's y-axis. Stretches and shrinks, again, we're going to skip horizontal for now. For vertical, notice that we have numbers out front, multiplying numbers out front. If the number is bigger than 1, remember it's a stretch. And if it's between 0 and 1, like a fraction or a decimal, then it's a shrink. All right, so let's jump right in and look at a few examples of this because I think y'all get kind of the main idea there. This one we're going to skip because it has a horizontal trend, horizontal, what is it called? Horizontal shrink and stretch. Okay, so here's our original. Here's how we changed it. I like to start on the left side or on the right side. So we have a plus 4, but it's inside parentheses. So that's going to be left 4. And ignore my handwriting, guys. I'm writing with my mouse, so sorry about that. So we're going to left 4. And then we also have a 2 added out front. 2 multiplied by this whole thing, so that's going to be a stretch. Because it's bigger than 1. And it's a number multiplied out front. And I think that's the only things we added into this one. All right, for these second two, we're going to be writing the function ourselves. So here's the original function we start with. But then let's see what we're adding into it. Let's see, we have a reflection in the x-axis. We're going 4 units right. I guess that's only 2 things. So if it's reflection in the x-axis, let's go ahead and rewrite this. G of x equals. Reflection in the x-axis means that we're going to have a minus sign out front. So negative 2x to the x power. So minus sign out front. And then also, next we're going to be moving it 4 to the right. 4 to the right, we can put that inside the exponent. So this will be x minus 4 inside that exponent. Okay, if it was down 4, we would write it like this. Minus 4 on the end. But since it's to the right 4, we have to put it inside that exponent right next to the x. Inside the exponent. Okay, so there you go. There's your transformed function. All right, let's do one more. Here's our original logarithm. And then we want to move it 2 units upward. And then we want to have a stretch by a factor of 2. So let's go ahead and do that. Let's change colors here. So g of x equals, our original is log base 1/3 to the x. So we'll have log 1/3 x. And then we're moving it 2 units up, so that's going to be a plus 2 on the end. Now, if this was right and left, we'd put it in parentheses, but it's not right or left, it's upward. And then we're also stretching it by a factor of 2, so we'll multiply by a 2 out front. And it's, now, guys, be careful on this one. We're multiplying the whole thing by 2, because we moved it up 2 first, and then we're going to have a vertical stretch. So we have to multiply this whole function by 2. So really this becomes g of x, and that's why order matters on these sometimes. So we went 2 up first. Now we're going to stretch it by a factor of 2. So we're going to multiply everything by 2. So we're going to have 2 log with a base of 1/3 x and then plus, we multiply this by 2 as well, so we'll have plus 4. It's a terrible box, but this is your answer right here. My boxes aren't getting it much better, so we'll just leave it like that. All right, so that's transformations, guys. If you have any questions, be sure to leave me a comment or send me a message, and I'll get back with you. Thanks, guys, for watching. Hope you all have a great rest of your day, and I'll see you next time.